Morning, students. In last class, we have started the unit number 4, that is mobile transport layer. After that, we have a gap of 1 month. Just I will go through the previous topics. I will give the overview, and I will continue the topics where we have stopped. Okay, coming to the 4th unit, we have started mobile transport layer after mobile network layer. In this mobile transport layer, we have a topics just about TCP and what is traditional TCP, and what are the problems with traditional TCP. Later on, what are the improvements to the traditional TCP. We have already covered what is traditional TCP. Just I am repeating once again. All you know about the TCP. TCP is a transmission control protocol. TCP is transmission control protocol, which is the part of transport layer. The transport layer is having majorly two protocols. One is TCP, connection oriented protocol, and second one is UDP, user datagram protocol. Here, the TCP is the one of the core protocol of transport layer. And just I'm giving overview. If any one of you just missed the last classes, just listen the topics. Majorly, the TCP is having three major responsibilities we have. Those are already we know, we have discussed in computer networks also. The first major responsibility is it is providing in-order transport of data. It is providing reliable in-order transport of data. All we know about in-order and out of order. In-order means suppose the sender is transmitting packets. The packets must be sent in a order. Suppose the first packet needs to send first, after that second packet, after that third packet. This is called as in-order data delivery. This should happen by using TCP protocol. Reliable, this is the very important word we need to remember. Reliable means there is no, the maximum, there is a light possibility, there is a less possibility of data transmission failure in between the sender and receiver. Then that transmission is said to be reliable data transmission. This is a connection oriented protocol, right? Okay, by using this TCP protocol, we will achieve the reliable data transmission between the sender and receiver. So hence it is said to be, it will provide the reliable in-order delivery, the reliable in-order transport of data. Okay, next one. The second major responsibility with regards to TCP is control the congestion in the network. Control the congestion in the network. All we know about congestion. Congestion is nothing but a traffic in the network. Okay. What TCP will do? The TCP will control the congestion between the sender and receiver. That means in the network. Okay. This is the second responsibility of TCP. Next, third one is control the packet flow between the transmitter and receiver. Okay. Control the packet flow between the transmitter, nothing but sender and receiver. Here, controlling the packet flow between the sender and receiver is nothing but controlling the flow is nothing but, okay, suppose the sender is transmitting the data to the receiver. Okay, the sender sending transmission data rate and the receiver's receiving data transmission rate must be synchronized. That means suppose the sender is sending high data transmission rate, the receiver is receiving with low data transmission rate, then what happens? Overflow at the receiver end will be happen. Okay, in order to cover this overflow problem, okay, what we need to have? We need to synchronize the sender and receiver. Here the synchronization means sender data transmission and receiver data transmission will be synchronized. Okay, then only the overflow at the receiver may not happen. The overflow at the receiver may not happen. Okay, this is known as packet flow. Control the packet flow between the sender and receiver. Okay, these three are the major responsibilities or properties of TCP. Okay, now already we have seen this diagram, the left side one. These are the different protocols at each layer. These are the Ethernet, ISDN modems, PLC. These are the different protocols which is having at the physical layer, and these are the protocols at data link layer, after that network layer, transport layer. Now we are here, TCP, UDP, DCCP and SCTP. Now we are discussing about TCP. Okay, after that these are the several protocols of application layer. Okay, now we are moving down to the next topic, that is congestion control. Already this topic has been covered in the previous sections. Okay, just I will give you the overview on this one. Congestion control. Already we discussed this congestion control in TCP. This is the one of the responsibilities of transmission control protocol. Okay, here congestion control is nothing but controlling the traffic in the network. Controlling traffic in the network. Suppose we have more traffic in the network. What happens? There might be a delay in transmission. There might be a delay in transmission. This delay leads to retransmission of the data sometimes. Sometimes it may leads to retransmission of data. Okay. To solve this congestion control problem, we have used two mechanisms. One is slow start mechanism and second one is fast retransmit or recovery mechanism. Just we'll go through the slow start mechanism. Here, before going to explain about slow start mechanism, just see this diagram. Here in the x-axis we have timestamp, that is time, and the y-axis we are having the congestion window size. We are having the congestion window size. The x-axis is having time and y-axis is having the congestion window size. This will be in segments. Okay, see here in slow start mechanism, what happens is very simple mechanism. Here, just listen my points. The sender sends initially, the sender sends one packet and waits for an acknowledgement. Okay. Suppose the first initially the sender sends one packet and he waits for an acknowledgement to the sent packet. After receiving the acknowledgement, okay, after receiving the acknowledgement, what the sender will do? The sender increases the congestion window. The sender increases the congestion window by 1. Initially, the congestion window size is 1. So that what he will send? He will send one packet. After arriving the successful acknowledgement, the sender increases the congestion window by 1. Now the congestion window size becomes 2. The congestion window size is 2. Now what he will do? He will send 2 packets. After receiving successful acknowledgement for those 2 packets, what he will do? He will increase the congestion window double. He will by 2. 2 becomes to 4. 4 becomes to 8 and so on. Okay, in this mechanism, after every successful acknowledgement which is received from the receiver, the sender will increase the congestion window by 1. After that it will becomes to 2. That means he will always doubles the congestion window size. In this case, we will face some problem. At one point of time, the congestion window size will be rapidly increases. Okay. For this situation, what we will do? See this diagram. Now see the diagram. Initially, see. First, the sender will send. See my cursor point here. This is segments. First he sent one segment. Okay. After receiving the acknowledgement, after some time, the sender receives an acknowledgement. After receives the acknowledgement, what he will do? He will increases the congestion window by 1. 1 becomes to 2. See, here 2 segments he sent. After receiving the acknowledgement, 2 becomes to 4. After that, 4 becomes to 8. 4 becomes to 8. Here at one point of time, this point of time is called as threshold point. This point of time is called as threshold point. Okay. Till this point, the congestion window growth will be, see, 0, 1 becomes to 2, 2 becomes to 4, 4 becomes to 8. You see the left side, you will find the first 1, after that 2, after that 4, after that 8. Till 8 segments, the growth of congestion window will be exponential. Exponential growth means every time after receiving the acknowledgement, the sender will increases the congestion window. He will doubles the congestion window. Okay, till 8 segments. See here, at one point, this point is called as slow start threshold point. From this point, the congestion window growth will be like linear growth. Linear growth means after receiving acknowledgement, the growth will be 1, 1, 1. Here, see 8, after that 9, after that 10, 11, 12, and so on. Okay, why we have slowed down the congestion window size after the slow start threshold point? This point we need to remember. Okay, if we do not decrease the congestion window size, what it will become? The congestion window will grow rapidly. Why? Because it is the exponential growth. Okay. Okay, for this congestion avoidance, we have done like this. In this, we have a small problem. Till 8 segments, the transmission is having fast. After that, the growth will be like linear. Okay. To solve this problem, we have another alternative in slow start mechanism that was similarly as previous diagram. The x-axis is having the time, y-axis is having the segments. See here, according to the slow start mechanism, initially 1 segment, after that 2 segments, after that 4 segments. Those who misses the last classes, just listen my words. First, initially sender sends 1 segment. After receiving positive acknowledgement, the sender will increases the congestion window by 1. That means window becomes to 2. Then the sender will send 2 segments. After 2, it becomes to 4, it becomes to 8. Here at one point of time, that point is called as slow start threshold point. Here 8 is the slow start threshold point. After this threshold point, till this threshold point, the growth will be like linear growth, sorry, exponential growth. After this point, the growth will be like linear, 8, 9, 10, and so on, the 20. At one point of time, that means after timeout, we will go back. Okay, next after timeout, we will start from 1. First, initially, we will send 1, after that 2, after that 4, after that 8. Here, see the difference between first time interval and second time interval. This is the in between, this one represents timeout. Okay, between the first time interval and second time interval, in the first time interval, the slow start threshold point is 8. After that, the slow start threshold point becomes to 10. In this means till 10 segments, it will go exponential. After 10 segments, 11, 12, and so on 20. Why? Because the congestion window size is 20. It will become again, it will go down. Next, what will become the next slow start threshold point? 8 becomes to 10. Next 10 becomes to 12. Here, after every timeout, that means for every time interval, the slow start threshold point will be increased. That means the transmission performance will be increased. Okay. This is the first technique. Already these topics we have covered in previous sessions. Just next one. The second alternative for for congestion control is fast retransmit or fast recovery. Here, this is very simple and theoretical. Here, what happens? The congestion control can be reduced because of two reasons. The threshold, the congestion control, not control. The congestion threshold is reduced because of two reasons. The first reason is the sender receives continuous acknowledgement. Suppose you are receiver, I am sender. First, initially, I will send one segment. After that, you will send me acknowledgement. After that, I will double congestion window. Then I will send two. You will reply an acknowledgement again 4, 8, and so on. That means the sender receives continuous acknowledgement for the same packet. The sender is receiving the acknowledgements like that. Now here the problem is, if the sender is receiving the continuous acknowledgement for the same packet, that means this point is very simple. Suppose I send a packet 1. You are receiver. What you will send, being a receiver, you send me an acknowledgement. Okay. After that, what I need to do? I need to send further packets. Okay. In this time, in between this time, what you will do? You are sending acknowledgement for the previous packet only. That means you are sending acknowledgement for the same packet. That means what is your intention? You need another packet. You need next packet. Okay. That point here mentioned. See, if the sender receives continuous acknowledgement for the same packet, it informs the sender that the receiver has got all the packets up to acknowledged packets. Suppose you send ACK3. What is the meaning of ACK3? Already you have received packet 1, already you have received packet 2, already you have received packet 3. This number, acknowledgement number, indicates up to that packets you have received successfully. Okay. Now, the fast retransmit or fast recovery, how it will control the congestion. How it will control the congestion. See, here, suppose, very simple technique. Sender sends 5 packets to the receiver. Sender sends 5 packets to the receiver. What the receiver will do? The receiver sent acknowledgements to the received packets. Okay. What the sender will expect within the timeout, అంటే సెండర్ సెండ్ చేసిన ప్యాకెట్స్ టైమ్ అవుట్ అయ్యే లోపల వాటన్నిటికీ అక్నాలెడ్జ్మెంట్స్ రావాలి. If the sender fails to receive the acknowledgements within the timeout, what the sender will do? The sender will retransmit the packet. ఇక్కడ ఏంటంటే ప్రాబ్లం ఏంటంటే, ఫాస్ట్ retransmit or recovery means the sender can ఇక్కడ ఏంటంటే ఓన్లీ మిస్ అయిన ప్యాకెట్స్ వరకే రీట్రాన్స్మిట్ చేస్తారనమాట. ఇన్స్టెడ్ ఆఫ్ సపోజ్ ప్యాకెట్ 1, ప్యాకెట్ 2, ప్యాకెట్ 3, ప్యాకెట్ 4, ప్యాకెట్ 5. ఇక్కడ ఒక ప్యాకెట్ మిస్ అయితే నార్మల్గా ఏం జరిగింది, అన్ని ప్యాకెట్స్ మళ్ళీ రీట్రాన్స్మిట్ చేయటం కన్నా కానీ ఏ ప్యాకెట్ మిస్ అయిందో, వెదర్ ద ప్యాకెట్ 3 or 4 or 5, which packet we have misses an acknowledgement, those packet will be retransmitted. ఓకే, అంటే అన్నిటిని మళ్ళీ రీట్రాన్స్మిట్ చేస్తే కంజెషన్ ఎక్కువైంది అనమాట. ఓకే, those packets which misses the acknowledgements will be retransmitted. Okay, this is the another technique of congestion control. Next one, this one also covered in previous class, the problems with traditional TCP in wireless environment. Already we have two major protocols, two major core protocols in transport layer. Already we have studied, discussed in computer networks. Now here also we are discussing TCP and UDP. Now TCP is a connection oriented protocol and UDP is the connection less protocol. Here the TCP is facing some issues in wireless environments. Why? Because TCP is a connection oriented protocol. Here we are using the wireless environments. So some problems may arise. Just look into the problems. First one, here, the slow start mechanism in a fixed network decreases the efficiency. Already I told you. What is the functionality of slow start mechanism? Initially, sender sends a packet. After receiving the acknowledgement, he will increases the increases the congestion window size. After that, and so on. Okay, in this case, if a sender fails to get an acknowledgement, if sender fails to get acknowledgement from the receiver, what the sender will do? Sender stops the transmission. If the sender stops the transmission, what happens? It will the decreasing the efficiency, decreasing the efficiency. Okay, in this way, the slow start mechanism in the fixed network decreases the efficiency of the TCP. Why? Because all the time it needs to wait for the acknowledgement. After receiving the acknowledgement only, it will able to send the further packets. This is the one disadvantage. And second one, error rates. Second point, error rates on wireless links are orders of magnitude higher. అంటే ఏంటంటే ఇక్కడ సింపుల్, normal error rate in wireless networks will be high when compared to normal. The error rates will be high in wireless network rather than wired networks. This is the one more problem. Next, the mobility. The mobility means we are using mobile devices. Always the device is moves from one place to another place. Due to this mobility, it may leads to a packet loss. Okay. Why? Because due to mobility, due to mobility, some handover procedures may be done. In these handover techniques, there might be a possibility of packet loss or data loss and everything. Okay. Now these are the major problems with traditional TCP. Okay. In order to cover this traditional TCP, we have some improvements to the traditional TCP. These are called as classical TCP improvements or traditional TCP improvements. Okay. The first classical TCP improvement is ITCP. That is indirect TCP. Just this one also we have covered in previous classes. Just I will tell you, I will explain the diagram. See here, see what is in the picture. We have a mobile device. We have the access point. Access point is nothing but a foreign agent. Okay. Access point is nothing but a foreign agent. Why? Always the mobile host is under the foreign agent. Always the mobile host is under the foreign agent. So first component is mobile device. Second component is foreign agent. Third one is fixed computer. Third one is the fixed computer. This will uses the wired network. This will uses the fixed computer or desktop system. This uses the wired internet, and this uses the wireless TCP. Wireless, and this uses the wire. Here in indirect TCP, see what happens. Just if you see this diagram, you might understand clearly. See, we have a mobile node, a mobile device. This is a foreign agent or access point, and this is the corresponding node. This is called as CN, means corresponding node or fixed node. Okay, corresponding node or fixed node. See, the connection is very important. This foreign agent or access point and this corresponding node are connected in a fashion of wired network. And this mobile node and foreign agent connected in a fashion of wireless mode. These two are in wireless, these two are connected with wire. See, our topic is indirect TCP. Our topic is indirect TCP or ITCP. Now, in this scenario, the transmission between mobile node and corresponding node, and as well as corresponding node to mobile node, how it will be done means, first see, the intention of mobile node is to transmit a packet to the corresponding node. Okay, the intention of mobile node is to transmit a packet to corresponding node. See what it has done. It sends a packet. In between the mobile node and corresponding node, we have a foreign agent. We have a foreign agent. Here, the foreign agent absorbs the packet. It will accept the packet which receives from the mobile node. And what the foreign agent will do? It will send the acknowledgement to the mobile node. అంటే ఏంటంటేనమ్మా, మొబైల్ నోడ్ కి కరెస్పాండింగ్ నోడ్ కి మధ్యలో ఫారెన్ ఏజెంట్ ఉంది. Our topic is indirect TCP. The mobile node sends a packet to the corresponding node. In between the mobile node and corresponding node, we have a foreign agent. Foreign agent ఈ packet ని receive చేసుకొని it will send acknowledgement. Then what mobile node will do? Mobile node will thought of, it will receive acknowledgement from corresponding node. It will receive the acknowledgement from the corresponding node. Then what the foreign agent will do is, it will send a packet. Foreign agent will send a packet to the corresponding node which is received from mobile node. Mobile node నుంచి రిసీవ్ చేసుకున్న ప్యాకెట్ ని foreign agent corresponding node కి transmit చేసింది. Then what corresponding node will supposed to think, okay, I got a packet from this foreign agent. Then what it will do? It will send the acknowledgement to the foreign agent. Here, who is the actual sender? Mobile node is the actual sender. Mobile node is the actual sender. Then to whom it sent? The packet sent by mobile node is received by foreign agent. Okay, here one problem arises. Who is the actual receiver? Corresponding node. Corresponding node packet actually receive అయింది, కానీ ప్రాబ్లం ఏంటి? అది ఫారెన్ ఏజెంట్ దగ్గర నుంచి వచ్చింది అనుకుంటుంది. Okay, here the major problem is the end-to-end semantics between corresponding node and mobile node will be misses. అంటే సెండ్ చేసింది కరెస్పాండింగ్ నోడ్ అని మొబైల్ నోడ్ కు తెలియదు, మొబైల్ నోడ్ అంటే ఒకళ్ళకి తెలియదు అంటారు. అంటే మిస్సెస్ the what semantics, misses the semantics, end-to-end semantics ఇక్కడ మిస్ అవుతాయి అన్నమాట. Similarly, see the reverse action. కరెస్పాండింగ్ నోడ్ సెండ్ చేసిన ప్యాకెట్ ఫారెన్ ఏజెంట్ రిసీవ్ చేసుకొని ఫారెన్ ఏజెంట్ అక్నాలెడ్జ్మెంట్ ఎవరికి ఇచ్చింది? కరెస్పాండింగ్ నోడ్ కి ఇచ్చింది. యాక్చువల్గా ఎవరు పంపిద్దాం అనుకుంది కరెస్పాండింగ్ నోడ్? కరెస్పాండింగ్ నోడ్ వాంట్స్ టు సెండ్ ద ప్యాకెట్ టు ద మొబైల్ నోడ్. ఇన్ బిట్వీన్ ఫారెన్ ఏజెంట్ దీన్ని తీసుకొని acknowledgement corresponding node ki ichesindi. Now foreign agent will acts as original sender and sends a packet to the mobile node. Then mobile node will send the acknowledgement to the foreign agent. Ikkada anta transmission anta bane undi. There is no delay, there is no lost in the transmission లేదు ఇక్కడ. There is no delay, but delay కొంచెం ఉంది. Actually delay ఏంటి? This is the delay and this is the delay. ఓకే, ఇక్కడ end to end semantics అనేవి లాస్ట్ అవుతున్నాయి అన్నమాట. ఓకే, see we have some advantages and disadvantages. Mainly we need to discuss about disadvantages in this indirect TCP. Those are loss of end-to-end semantics. Loss of end-to-end semantics. నా దగ్గర నుంచి ప్యాకెట్ ఎవరికి వెళ్ళాలి? కరెస్పాండింగ్ నోడ్ నుంచి మొబైల్ నోడ్కి వెళ్ళాల్సింది వెళ్ళట్లేదు. మొబైల్ నోడ్ నుంచి డైరెక్ట్ అక్కడ రావాల్సిన అక్నాలెడ్జ్మెంట్ నాకు రావట్లేదు. మధ్యలో ఎవరు తీసుకుంటున్నారు? యాక్సెస్ పాయింట్ ఆర్ ఫారెన్ ఏజెంట్ విల్ యాక్ట్స్ యాజ్ ఒరిజినల్ సెండర్. In between the sender and receiver, the access point will acts as original sender. Okay, this is the problem. The second one ఏంటంటే security problems. Security issue అంటే ఏంటి? Foreign agent అంటే ఏంటి? It must be a trusted entity. Why? Because the end to end transmission మధ్యలో ఎవరైనా ఉన్నారంటే ఏంటంటే we need to trust that must be a trusted entity, otherwise the data will be lost. Okay, this is the first one, that is indirect TCP. The next one is snooping TCP. First, in indirect TCP we have so many problems. The major problem is end-to-end semantics might be lost and the security problem will be high. High means it must be, the foreign agent must be a trusted entity, otherwise it will become a problem. If it is not a trusted entity, it will become a problem. Now, the one more improvement to the classical TCP is snooping TCP. Already you have well aware of snooping, sniffing, sniffer, snooping in cryptography and network security. These words may repeatedly come, snooping and sniffing everything. See, very simple procedure. Similarly, we have in the indirect TCP, we have a mobile host and foreign agent corresponding node. These two are connected in wired, these two are connected in wireless. See, first we'll go to the diagram and after that we'll come back. See, first diagram represents corresponding node to mobile node packet delivery. The second diagram indicates mobile node to corresponding nodes. First we will see from corresponding node to mobile node. First, see, corresponding node sends packet to the mobile node. Directly it will go to the mobile node via foreign agent. Here the foreign agent will keep one copy of data. అంటే foreign agent నుంచి ఏ ప్యాకెట్ వెళ్ళినా కానీ one copy of data దాని దగ్గర పెట్టుకుంటారు, duplicate copy of data దాని దగ్గర పెట్టుకుంటుంది అనమాట. ఓకే, similarly for the received packet the mobile node sends acknowledgement. ఇక్కడ కూడా the acknowledgement packet ని కూడా one copy of data will be kept at foreign agent. దీన్ని ఏమంటామంటే స్నూపింగ్ అంటాం అనమాట. ఎవ్రీ డేటా విచ్ ఈస్ పాస్డ్ via or passed through the foreign agent, it will keep one copy of data. This is called as snooping antaru. This is called as snooping. That's the reason why it is called as snooping TCP. That is called as snooping TCP. Here the packet is snooped here, the acknowledgement is snooped here. Now we see the second case. The packet sent from corresponding node, it passes through foreign agent and the packet lost in between the foreign agent and mobile node. That means in between the access point and mobile node. ఇక్కడ నుంచి ఇది యాక్సెస్ పాయింట్ ఫారెన్ ఏజెంట్ దాటింది అంటే మీనింగ్ ఏంటి? ఇట్ విల్ కీప్ 1 కాపీ ఆఫ్ డేటా కదా. ఓకే ఓకే. The packet sent through foreign agent at one point of time. After some point of time, what it will expect? Foreign agent ఏం చేసింది? నా నుంచి ఇటు ప్యాకెట్ వెళ్ళింది కదా, ఇటు నుంచి మళ్ళీ అక్నాలెడ్జ్మెంట్ కూడా వెళ్ళాలి కదా అని ఎక్స్పెక్ట్ చేస్తుంది అనమాట. ఇట్ విల్ ఎక్స్పెక్ట్ an acknowledgement. Why? Because already the packet is sent via foreign agent. So after some point of time it will not get an acknowledgement. Then this timeout, after this timeout period, ఆల్రెడీ ఒక ప్యాకెట్ ఆఫ్ డేటా దీని నుంచి పాస్ అయిందంటే ఒక ప్యాకెట్ ఆఫ్ డూప్లికేట్ డేటా ఇక్కడ ఉంటుంది కదా. సో ఈ ప్యాకెట్ని ట్రాన్స్మిట్ చేసేసింది. ఇక్కడ స్టోర్ చేసుకున్న ప్యాకెట్ అంటే ఇటు నుంచి అక్నాలెడ్జ్మెంట్ రాలేదు అంటే మీనింగ్ ఏంటి? ఓకే, ప్యాకెట్ లాస్ట్ అయింది అనుకొని ఆ డూప్లికేట్ ప్యాకెట్ని ఏం చేస్తుంది? ఇక్కడికి ట్రాన్స్మిట్ చేస్తుంది. నార్మల్గా ఎవరు ట్రాన్స్మిట్ చేయాలి? ఒరిజినల్ సెండర్ నీడ్స్ టు రీట్రాన్స్మిట్ ద డేటా. హియర్ హూ విల్ సెండ్ ద రీట్రాన్స్మిషన్? ఫారెన్ ఏజెంట్ డన్ ద రీట్రాన్స్మిషన్. దీన్ని ఏమంటామంటే ఫాస్ట్ లోకల్ రీట్రాన్స్మిషన్ అంటామండి. దీన్ని ఏమంటామంటే ఫాస్ట్ లోకల్ రీట్రాన్స్మిషన్. ఇప్పుడు మొబైల్ నోడ్ ఏమనుకుంటుంది? మిస్ అయిందన్న ఇన్ఫర్మేషన్ మొబైల్ నోడ్కి తెలియదు, ప్యాకెట్ వచ్చిందని అనుకుంటుంది అనమాట. సో ఇట్ విల్ సెండ్ ద అక్నాలెడ్జ్మెంట్ టు ద రిసీవ్డ్ ప్యాకెట్ అండ్ సో ఆన్. Here the advantage is fast local retransmission. Actually, for the missed packets, the sender needs to retransmit once again. Here, who will perform the retransmission? The access point or foreign agent done the retransmission. అక్కడ మిస్ అయింది అనే ఇన్ఫర్మేషన్ అనేది మొబైల్ నోడ్కి తెలియదు, కరెస్పాండింగ్ నోడ్కి తెలియదు అనమాట. ఓకే, దిస్ ఈస్ ద ఫస్ట్ కేస్ ఇన్ ద స్నూపింగ్ TCP. The second case, reverse. In the first one we have seen from corresponding node to mobile node. Here we are seeing mobile node to corresponding node. Mobile node to corresponding node. First mobile node sends packet, it passes through foreign agent and received by corresponding node. Packet, second one also packet is done, reached successfully, acknowledgement reached successfully. మనం అర్థం చేసుకోవాల్సింది ఏంటంటేనమ్మా, every packet or acknowledgement passes through the foreign agent in the snooping TCP. One copy of data will be kept at foreign agent. Next, packets are transmitted. See the cursor point. Packets are transmitted. Next, packet transmission between the mobile node and foreign agent will be corrupted. చూడండి, ఇక్కడ మొబైల్ నోడ్ కి ఫారెన్ ఏజెంట్ కి మధ్య ప్యాకెట్ లాస్ట్ అయింది. ప్యాకెట్ లాస్ట్ అయినప్పుడు ఆల్రెడీ ప్రీవియస్గా ప్యాకెట్స్ వస్తున్నాయి, సెండర్ నుంచి రిసీవర్, మొబైల్ నోడ్ నుంచి కరెస్పాండెంట్ ప్యాకెట్స్ వస్తున్నాయి. బట్ హియర్ ద ఫారెన్ ఏజెంట్ డిటెక్ట్స్ ఎ గ్యాప్. In the data. So here this point, it has detected the gap. ఈ ప్యాకెట్ మిస్ అయింది కదా, నెక్స్ట్ ఇంకొక ప్యాకెట్ పంపించేస్తుంది. సెండర్ వితౌట్ సీయింగ్ ఆల్ దీస్ ఇట్ సెండ్స్ ద ప్యాకెట్ కంటిన్యూస్లీ. ఇక్కడ ఒక గ్యాప్ వచ్చింది కదా, చూడండి ఇక్కడ ఈ పర్టికులర్ గ్యాప్ వచ్చిన ఇన్ఫర్మేషన్ ఏం చేస్తుందంటే, సెండర్ ఏం చేస్తుందంటే, యాక్సెస్ పాయింట్ ఏం చేస్తుందంటే, త్రూ నెగటివ్ acknowledgement, it will intimate it to the sender. ఇప్పుడు నాకు మీరు సెండర్, నేను రిసీవర్ అమ్మ, మీకు నాకు మధ్యలో ఒక ఫారెన్ ఏజెంట్ ఉన్నారు. నేను ప్యాకెట్ పంపించాను. ఆఫ్టర్ 1 minute ఇంకొక ప్యాకెట్, తర్వాత ప్యాకెట్ పంపించాను, కానీ నాకు ఫారెన్ ఏజెంట్ మధ్యలో ప్యాకెట్ లాస్ట్ అయింది. ఫారెన్ ఏజెంట్ ఏం చేస్తుంది? ఫర్ ఎవ్రీ మినిట్ ఐఎమ్ గెటింగ్ ద ప్యాకెట్ ఫ్రమ్ ద సెండర్. Now it detects a gap. ఆ గ్యాప్ డిటెక్ట్ అయిందని చెప్పేసి ఏం చేస్తుంది, మధ్యలో ఫారెన్ ఏజెంట్ ఏం చేస్తుంది, ఇట్ విల్ సెండ్ ఏ నెగటివ్ ఎక్నాలజ్మెంట్ టు మీ. సెండర్ కి నెగిటివ్ ఎక్నాలజ్మెంట్ ఇస్తుంది. వై? బికాస్ నేను గ్యాప్ డిటెక్ట్ చేశాను, ఈ ఈ మధ్యలో ఏమన్నా ప్యాకెట్స్ పంపించుంటే కనుక అవి లాస్ట్ అయినవి, దోస్ ప్యాకెట్స్ విల్ బి రీట్రాన్స్మిటెడ్ అగైన్, మళ్ళీ వాటిని రీట్రాన్స్మిట్ చెయ్యి అని ఇన్ఫర్మేషన్ సెండర్కి ఇచ్చిందనమాట. ఎలా? బై ఎన్ఏసికే, నెగిటివ్ ఎక్నాలజ్మెంట్. సో ఇది కూడా ఫాస్ట్ లోకల్ రీట్రాన్స్మిషన్. నార్మల్గా ఎవరు ఇవ్వాలి ఎక్నాలజ్మెంట్? కరెస్పాండింగ్ నోడ్ ఇవ్వాలి, అంతే కదమ్మా. ఇక్కడ గ్యాప్ వచ్చిన ఇన్ఫర్మేషన్, ఈ ప్యాకెట్ లాస్ట్ అయితే హూ నీడ్స్ టు ఇంటిమేట్ ద సెండర్? ద రిసీవర్. ద కరెస్పాండింగ్ నోడ్స్ intimates to the sender about packet loss. Here who have intimated? Foreign agent is intimated to the sender regarding the packet loss. This is also one type of fast local retransmission which is intimated by foreign agent to the mobile node instead of corresponding node. Okay, this is all about snooping TCP. ఇక్కడ ఎందుకు స్నూపింగ్ జరుగుతుందంటే, one copy of data will be kept at foreign agent or access point. Now we'll come back to the diagram. This is the mobile host. Mobile host nunchi, from mobile host to the corresponding node, see one line. This is ante end-to-end semantics unnai. There is end-to-end semantics between sender and receiver. For every packet which is sent from the mobile host to the corresponding host, those will be snooped here. It నుంచి వెళ్ళే డేటా కానీ, అంటే మొబైల్ హోస్ట్ నుంచి కరెస్పాండింగ్ హోస్ట్కి వెళ్ళే డేటా కానీ, కరెస్పాండింగ్ హోస్ట్ నుంచి మొబైల్ హోస్ట్కి వెళ్ళే డేటా కానీ, both data will be snooped at access point. అలా స్నూప్ చేయటం వల్ల ఏం ప్రాబ్లం, అడ్వాంటేజ్ ఏంటి? చూడండి ఇక్కడ local retransmission. Already we have seen local retransmission. Here we have fast local retransmission. Here we have fast local retransmission. These two advantages we have done. Okay. Here one more improvement between compared to the ITCP to STCP. స్నూపింగ్ టీసీపీకి ఇండైరెక్ట్ టీసీపీకి ఒక అడ్వాంటేజ్ ఏంటంటే, హియర్ ద ఎండ్ టు ఎండ్ సిమాంటిక్స్ విల్ నాట్ బి లాస్ట్ బికాస్ just it will snoop the data in between. It will not act as a original sender. It will act as a foreign agent itself. Okay, see the advantages. The end-to-end TCP semantic is preserved. అంటే నేను సెండర్ని, మీరు రిసీవ్. ఇందాక ఎవరు మధ్యలో వాళ్ళు నేను పంపించిన డేటాని వాళ్ళు పంపించినట్టుగా, మీరు పంపించిన డేటా వాళ్ళు నాకు పంపించినట్టుగా యాక్ట్ చేశారు. ఇప్పుడు ఏంటి, నేను పంపించిన డేటా మీకు పంపించిన డేటా వాళ్ళు మధ్యలో వింటున్నారు తప్పితే మీకే రీచ్ అవుతుంది. సెండర్ నేను, రిసీవర్ సెండర్ నేను మీకు అర్థం అవుతుంది. ఇప్పుడు మీరు ఇచ్చిన ఆన్సర్ నాకు అర్థం అవుతుంది. బట్ ఏంటి, మీరు ఇచ్చిన ఆన్సర్ వాళ్ళు వింటున్నారు, నేను పంపించిన డేటా వాళ్ళు వింటున్నారు. నా దగ్గర నుంచి మీకు వచ్చే డేటాలో ఏమన్నా మిస్ అయితే కనుక వాళ్ళ దగ్గర ఒక కాపీ ఆఫ్ డేటా ఉంటుంది కాబట్టి వాళ్ళు ఫాస్ట్ గా రీట్రాన్స్మిట్ చేయగలుగుతున్నారు అనమాట. సో అడ్వాంటేజ్ ఏంటి, ఎండ్ టు ఎండ్ సిమాంటిక్స్ విల్ బి ప్రిజర్వ్డ్. అండ్ ఇంకొక అడ్వాంటేజ్ ఏంటి, ఫాస్ట్ లోకల్ రీట్రాన్స్మిషన్ ఈజ్ వన్ మోర్ అడ్వాంటేజ్. కమింగ్ టు ద డిసడ్వాంటేజ్ ఏంటి, స్నూపింగ్ అంటే ఏంటంటేనమ్మా, ఇక్కడ కూడా మనకి ప్రాబ్లం ఏంటి, ఒక కాపీ ఆఫ్ డేటా వాళ్ళ దగ్గర ఉంచుకుంటున్నారంటే మీనింగ్ ఏంటి, సెక్యూరిటీ ప్రాబ్లమే కదా. ఓకే, అండ్ ఇంకా ఇంతకుముందే నార్మల్గా ఏముండేది, ఓన్లీ పాజిటివ్ ఎక్నాలజ్మెంట్ ఉండేది. ఇక్కడ హియర్ వీ నీడ్ టు హ్యావ్ అడిషనల్ మెకానిజం, ఎన్ఏసికే కూడా యూజ్ చేస్తున్నాం కాబట్టి సెండర్ దగ్గర రిసీవర్ దగ్గర కొంచెం అడిషనల్ మెకానిజమ్స్ కూడా మనం మొబైల్ హోస్ట్ దగ్గర ఇన్స్టాల్ చేసుకోవాలి. అండ్ స్నూపింగ్ చేసుకునేటప్పుడు నా దగ్గర నుంచి డేటా వెళ్తుంది కదా, మధ్యలో కొద్దిసేపు బఫరింగ్ జరిగింది అనమాట. ఎందుకు, ఆ పంపే డేటా వాళ్ళు స్టోర్ చేసుకోవాలి కదా, ఒక గ్యాప్ ఫామ్ అవుతుంది. రిసీవ్ అవుతుంది, సెంటర్ నుంచి రిసీవర్ డేటా రిసీవ్ అవుతుంది, బట్ వన్ బఫరింగ్ హ్యాపెన్స్ ఎట్ యాక్సెస్ పాయింట్. ఎందుకంటే నా దగ్గర నుంచి మీకు వచ్చే డేటా వాళ్ళు స్టోర్ చేసుకోవాలి కదా, ఆ స్టోర్ చేసుకోవడానికి పట్టే టైం ఏంటంటే బఫరింగ్ టైం అంటాం అనమాట. దీస్ ఆర్ ద డిసడ్వాంటేజెస్ ఆఫ్ స్నూపింగ్ టీసీపీ. Okay, already these topics we have covered in previous classes, but I'm repeating once again. Why? Because we have almost 1 month 30 days gap. Okay, tomorrow we'll discuss about mobile TCP and next topics. Okay, thank you everyone. Okay, tomorrow we'll discuss the next classical TCP improvements. Thank you.